Okay, we're going to take a look at a 3D printed house. One of the unique features about these houses is that they are printed in a manner where they start along the bottom and they make courses of cement all the way up. It's very consistent work, really attractive. I'm a little concerned about the ledges that are created along each of the courses that are spit out from the machine, because over time, flushing of runoff from the wall, we can get erosion along the top edge of each of these. So that's a concern. Other than that, what we really want to look for on these are expansion joints at the windows, which these have. Lots of expansion joints, so it's very well done. Those are going to be the points at which deflection or settling of the building start to show cracking. So this will control all that cracking. Other than the expansion joints, we should have a weep hole system. Well, not exactly, because this is not like a stucco that's on framing. This is solid concrete, so we do not need a weep hole system for moisture to escape from the wall, because it's solid all the way through from exterior to interior. I appreciate the window fenestrations here that appear to be molded into the concrete work along this edge. It's got a nice slope to it, so that's going to drain very well. All the penetrations look to be very well developed and sealed. That looks excellent. Overall, there's not a whole lot to inspect on these 3D printed homes outside of the expansion joints and water shedding properly off the building. It's a great concept. Time will tell how it fares, but overall I think the idea and the design behind this idea is fantastic. Now this is out in Georgetown, Texas, which is pretty much solid rock. So Lannar and Icon, who built the 3D system, were very strategic in finding a location with a great substrate to park this house on top of. This particular development also has a standing seam roof with an excellent overhang. Excellent overhang. Noting that the foundation was formed square and the wall is curved, so we do have a flat section of a corner that may actually allow water to seep underneath the concrete. I don't see how there's any kind of built-up foundation like along the edge wall here, where you have the cement courses hanging up against the edge so that water flows off properly. This may be a point at which water can potentially seep in. I see it as a very, very slight possibility, but running off those corners would have definitely followed the curvature of the wall and thus prevented that from happening. So you do the corrugation of the courses that they have to use quite a bit of sealant to cover the gaps on the exterior penetrations. So that's kind of a slight downside, but they've done a good job with the sealing. At the top of the wall where the 3D courses stop, there's a gap at the metal soffit line. I saw some daddy long legs parked up in there up front, so that area being an opening is going to let pests in, so that area should have been sealed. Gap opening is where the soffit venting panels come together. There's a gap there that should be sealed up to prevent pests. A possible issue that may come up is we don't know what the overall R value or the manual J calculation for this building would be. It's about 2,000 square feet, 2014 to be exact, and there's a 3-ton unit, which seems a little large for me based on the efficiency of the walls. So I would, in this case, suggest that the buyer of the property consider having a conversation with the HVAC contractor and making sure that the system is not too big. With the low E double pane windows, the 3D courses being considered an incredibly high R value, and the metal roof being a reflective galvalume, I would assume that the R value of this building would be exceptionally good, and that we could stick a pretty small unit in here, maybe even up to a 2-ton unit. So this unit may, as a 3-ton, be oversized. So not only do you have the exterior walls 3D printed, but the interior walls are as well. pretty attractive. The only issue I see here really is how do you hang stuff on the walls? So that becomes an issue. There's a fairly large crack across the middle of the foundation, right around the kitchen area. That's a little excessive for me. You do always have shrinkage cracking, which occurs when you pour concrete, because concrete never shrinks. I mean, never expands, it always shrinks. But this does go from end to end. So it's a little bigger than I want to see on brand new construction. So in this case, I will recommend my client monitor it. All houses built in Texas are supposed to have a 10-year structural warranty. So that should be protected in case of structural failure. But of course, with the stained concrete floors, which I think are fantastic, except they get cold in the winter and they're extremely hard to walk on, unlike a wood or bamboo floor. So those cracks are always going to be there. They're never going to go away and likely will get worse. The same issue with the exterior outlets applies to the interior outlets as well. But this is just the nature of the beast. It's what you get when you get a 3D printed wall. Sticks out a little bit, but not too bad. Another suggestion I would make to Lannar is not to use sashes at every window. They can make several of these windows fixed and save some money. We're in Texas, we don't really open our windows too much, so kind of unnecessary to have sashes at every location. In closing, be aware that I have walked into this inspection with no preliminary research on this construction method. So everything I'm pointing out in this quick and dirty inspection is based on your standard conventional type construction. Nevertheless, though, I am incredibly impressed with the overall construction of the building. I just worry about, well, very little, honestly. I did also notice that these overhangs at the front and rear, those are pretty substantial. Those are probably 7 feet out. So those have to have some pretty good cantilever action going on, going back to support that overhang. So that's something I'm going to bring up in the report. But overall, I think you, with this product, have an incredibly efficient, well-built home. Really, I believe, built to and designed to last longer than your conventional framed home. So kudos to Lannar and Icon on their risk on building a home. It's very unconventional.